Assalamualaikum warahmatullahi wabarakatuh to all our viewers. I hope all of you are in great health condition. Today, we will present to you about the subtopic that we choose from ordinary differential equation subject, which is population growth. Okay, before we start our presentation, I will introduce our group members to you. First of all, I am Muhammad Aiman bin Azham. Next is Nik Muhammad Khairul Afif bin Muhammad Arif. And last one is Muhammad Khairul Afan bin Mustafa.
The global population has been growing quickly every year, driven by better healthcare, improved living conditions, and high birth rates in some areas. This growth has led world leaders to estimate future population trends to prepare for challenges like resource use, infrastructure, and sustainability. Mathematicians have created models to predict population change by looking at birth rates, death rates, and migration. This prediction help government plan for the future needs like healthcare, housing, and food. By understanding population growth, leaders can make better decisions to ensure resources are used wisely and communities are prepared for the future.
So we continue to introduction part. The main purpose for this group project is to calculate the population growth over time. Apart from that, we use a mathematical model based on the principle that the rate of population growth is proportional to the current population. This relationship is described by the differential equation dP over dt is equal to Kt. There are four steps to solve the population growth equation. Firstly, we separate the variable from dP over dt equal to Kt. We separate it to become 1 over P dP is equal to K dt. After that, we integrate both sides of the equation. We integrate 1 over P dP is equal to K dt to become Pt is equal to C e the power of Kt. C is constant and also stands for e the power of d. After complete both steps, we apply the condition given for solving the specific for unique solution. This step we wanted to get the specific number for each variable. Is useful for prediction of number of population at a certain time and to predict the time knowing a number of population. We continue to next part, which is problem statement. The problem statement is the initial number of population of Malaysia in 2019 is 32.52 million. After 3 years, the number of population increased to 32.65 million. Firstly, find the time required for the number of population to be 34.56 million. Second, the number of population at 2030.
Now, let's take a look to the problem solution. As my friend said before, the first thing to do is separate the variable and integrate the both sides in order to get the general solution for population growth. Step 2. By applying the information from the question that said the initial number of population is 32.52 millions. It means when times is 0, the population is 32.52 millions. Then we let t equal to 0 and we get c equal to 32.52. Then we get the new general solution with value c. Step 3. From the question that mentioned after 3 years, the population is 32.65 million, and we know when times equal to 3, the population is 32.65 million. Then we put it in new general solution to find value of k. After get the value of k, then we get the unique solution for population growth. Now we can answer the question 1. The question asks to find when the population becomes 34.56 million. So, the first step is we make the unit solution equal to 34.56 million. After some calculation, we get the t is equal to 45.75 and then we approximate it to the 46. In order to find the year, we need to plus it with 260 because that is our initial year. Then we get 2064. It means by 2064, the Malaysian population approximately become 34.56 million. Lastly, let's discuss for the questions too. The questions asks how much the population in 2030. So the first step is find the value of t. In order to find t, we minus 2030 by 2019. Then we get t is equal to 11. Then we substitute t with 11 in unit solution from before. Then we get approximately 33 million. So, when 2030, the Malaysian population will be 33 million. That is end of problem solution part. Now, I will pass to Aiman to talk about conclusion.
In conclusion, we can conclude that using ordinary differential equation can estimate the total number of certain population such as human, insect, virus or bacteria in certain time. Other than that, we also can predict the time based on total number population from the data. Therefore, ordinary differential equation is useful formula that can help people in this world predict certain population for the future. Okay guys, before we end our presentation, I hope all of you enjoyed our video and I also hope all of you can understand the population growth formula correctly and can be useful for your examination or in your daily life. I think that's all from us. Thank you and see you again.